Okay, so today's session we're going to look at time series, some foundation of time series analysis. And in the previous sessions, we started by looking at the basics of Python, the programming side, where we looked at variables, data types, conditional statements, control structures, loops, and stuff like that. So those are very, very important. The basic part is very, very important because you will always build on top. You will always be building on top of those foundational skills. And then we also further looked at exploratory data analysis, where we were able to look at how we can select column, how we can select rows, how we can access the elements of our data using pandas, using NumPy, and some data visualization. So those are some of the things that will be meeting in your project on how you can be able to handle your data, load your data, and then be able to do some kind of visualization. And then from there, you can now make a decision based on the data that you will have. And then we also looked at some regression analysis, which is very important, where we can be able to discuss about how one variable affects another variable. So we looked at correlation. Which shows the relationship between two variables in the data. And then we also plotted correlation matrix, so you can be able to see how different relationships vary within different data variables. So, and then we also looked at hypothesis testing, where we introduced the null and alternative hypothesis, where we can be able to use those concepts to be able to make informed decision. And then we also looked at analysis of variance, which is ANOVA, one-way and two-way, where we were able to look at one way where we have a categorical variable and one continuous variable. So we try to see how this categorical variable affects or has an influence or an impact on the continuous variable, which is response. And then in two-way ANOVA, we have two categorical variables. And now we look at how these two categorical variables are influencing the new, how are they influencing the response variable. Those are very, very insightful things that we looked at. And it is very, very important to have that foundation as it builds our knowledge or understanding about data analysis. So today we are going to look at something different, and it's not that different, but is very, very widely used. So we'll just be looking at the introduction part of it, but in our advanced concepts, which is the professional level of data analysis in Python, you can go in depth into these concepts. So let me start by sharing my screen so that we can know what we are going to cover today. So sharing my entire screen. So then you can just confirm that you are able to see my screen.
Yeah, it's coming up.
Okay. Once it's ready, let me know.
Oh, it's ready.
Okay. All right, so beyond data set solutions, so we start with the introduction to time series analysis. So time series analysis, as you can see, what is time series analysis? By definition, a time series is a sequence of data points collected or recorded at specific time intervals, often over a consistent period of time. So, for example, we can have stock prices, we can have daily temperature readings, we can have monthly sales data and economic indicators. So these are just some of the time series data, types of time series data. We can have, as long as our data has time and the data is collected at a specific time interval, maybe daily, maybe after 1 hour, maybe after 2 minutes, maybe after 1 second, maybe after 1 week, after 1 month, and stuff like that. So once data is periodic, then it is defined to be time series data. So it is very important for businesses, organizations, to be able to look at how events occur after a specific time interval. So there is where now the concept of time series come. So from there, maybe some concepts of which are the components of the time series analysis. Components of time series, one is trend. So trend is the long-term progression of the series, indicating an upward or downward movement. So when we look at our data, we should be able to detect if it has these components. So we look at if our data has trend. So in time series analysis, we are usually interested in checking the existence of these components in our data. So the second component is seasonality. So seasonality is where regular patterns or cycles in the data that repeat at fixed intervals. So seasonality is where we can be having these trends, let me call them trends, happening within a time of less than 1 year. The easiest way of defining seasonality is where we can be having trends happening within a time bound of less than 1 year. So it can be either monthly, it can either be quarterly. So while cyclic patterns, these are now, we call them irregular fluctuations due to economic or other cycles, but now they are longer than the seasonality. So that means once it's beyond 1 year, we call it cyclic patterns. Once we have trends that are more than 1 year, we call them cyclic patterns. But if they're less than 1 year, we call them seasonality. Yes, we call them seasonality. These are some of the concepts of time series analysis. And we usually look at this so that we can be able to know what are actually the reasons as to why there is stock price fluctuation. Why is it that we have different temperatures readings? Maybe we can use also time series to predict or to forecast the weather conditions, if it is going to rain or it's not going to rain. So it is very, very important. And this concept is usually used in the meteorological department to be able to predict some circumstances that may likely to happen. We usually ask ourselves, how is this possible? So it is just through the time series analysis where we look at historical data and we uncover some common insights out of it. And then noise is also another component of time series where we may not confidently say that the reason as to why this component is happening is this. The reason as why we're having trend is this. So some of these things may happen due to noise. Like noise is something that you cannot control. Like is not a specific component. It's a random variation that cannot be attributed to trend, cannot be attributed to seasonality. Like you just see, it's not a trend. Like you just see an abrupt upward and then again downward. So that one is something like noise. This is a random variation that we cannot say that it's a trend, and we cannot even say that it's a seasonality or it's not even a cycle. So those are the 4 components of time series. So the difference between trend, seasonality, cyclic patterns, and the noise is that trend is just the long-term progression of the series, indicating an upward or a downward movement. And then we go further. When this trend is less than 1 year, we call it seasonality. When this trend is beyond 1 year, we call it cyclic. And when we see a pattern, or when we don't see like a pattern, we just see an upward or a downward movement that is just random, then that one is noise. So whenever you have noise, that means our maybe we look at the downward concepts, the concepts in time series, then we can be able to relate to the 4 components. So every time you deal with time series data, is good for you to look at these key components if they exist in your data. So let's look at some key concepts in the time series analysis. So the first concept is stationarity. So stationarity time series has properties such as mean and variance and do not change over time. What we are trying to say is that in a stationary time series, we can be able to, of course, stationary means that mean and variances of our time series data does not change over time, like it's constant. That's what we mean by stationary. While non-stationary is where they change over time. So they often need to be transformed to become stationary for effective modeling. So before you model your time series data, before you do what you do forecasting, you have to check for stationarity of your data. If it is not stationary, it is known as non-stationary. And then now you have to change your non-stationary data to stationary before you do any modeling. Modeling is where now we go to the next concept that will be coming as the time series model. So before you perform any time series model, you need to ensure that the state of your time series is stationary. And then we have some key concepts here under time series. Another one is autocorrelation. So the correlation of a time series with its own past values. So helps in identifying patterns and model parameters. So autocorrelation in this case, it's just like in other types of data where we usually talk about multicollinearity, where we have existence of relationships between a time series data with its own past values. That's what autocorrelation is. So we usually check, these are some of the things that we usually check in our time series data to figure out if autocorrelation exists or not. If it exists, then we have to perform differencing. So there's where the concept of differencing comes in. So it's a method to make a time series stationary by subtracting the previous observed observations from the current observation. So ways of which we can be able to change also our time series data. So like autocorrelation helps us to detect if our data is stationary or not. It's just a concept that helps us to detect. It produces some values that help us to determine if our time series is stationary or not, irrespective of the visualization of the time series data. But we have to look at some values that come as a result of autocorrelation. And now we look at the theoretical interpretation to check if the data is in a stationary state or not. And then if it is not, now we perform what we call differencing for us to be able to change the time series from non-stationary state to the stationary state. And then we look at some concepts, common models in time series. This we are just introducing this so that we know that they exist. We are not going to go into details of each of these models, but it's good to know they exist so that we can do more research on them because they're in the advanced concepts of professional Python data analysis. So what is ARIMA? So the first concept we meet in time series model is ARIMA model. If you have ever heard of ARIMA model, maybe George, have you ever heard of ARIMA model? George?
Yes, I'm here. I was trying to.
Yeah, have you ever heard of ARMA? ARMA and ARIMA model.
ARIMA model, I think I've heard of it. I'm
Yes,
currently
yes,
doing my research, and
yes,
I've seen some students coming up with more
yes,
those models. As I'm going to do my
yes,
research
yes,
on ARIMA model, blah blah blah. Last week we saw ANOVA, so I've seen those
yes,
in proposals
yes,
from
yes.
some of the students.
Yes,
Yes.
that's interesting. Yeah, so first of all, we have ARMA, which is autoregressive moving average, ARMA, without I. So autoregressive moving average. And then we have ARIMA. So ARIMA is the autoregressive integrated moving average. So we have like three parts in ARIMA. We have three parts. So the first part is AR, which is autoregressive. So autoregressive part, this is the regression of the series on its own past values. And then I is the integrated. So differencing to make the series stationary. And then MA is the moving average. So before you look into the time series model, you must look at autoregressive part and you must look at average. When you look at the ARMA. And then when you are looking at ARIMA, you have to look at the autoregressive and then check if the differencing is required. You do the integrated part, and then you do the MA, which is the moving average part, which refers to the modeling the error term as a linear combination of past error terms. This is the theoretical part of this mathematics is very interesting. The theoretical part of this mathematics is very interesting, and it really requires you to scratch your head to know in which direction are you moving. Yeah, so that is the first aspect, which is the ARIMA. The second one is SARMA. This is another type of time series model. So it's a seasonal ARIMA. Like it's an extension of ARIMA that accounts for seasonality by including seasonal terms. So all these models all depends with your data, the kind of data that you have, and which model is appropriate. You have to look at the P, the D values. So there's a lot of things, theoretical part that you need to learn before you can dive deeper into the modeling of the time series data. And then exponential smoothing. This method is just like simple exponential smoothing. So these are also other types of time series model that focuses on the weighted average, which looks at the past observations, and then it does its computing for it to predict the time series model. So maybe we move forward and look at the steps in time series analysis. We are just introducing the models. We are not going to predict using these models in this foundational level. This level is the time series level is beyond this foundational level. So we cannot go into details into it. It's good to know that they exist and we know how time series data work. So we are going to see what you can be able to learn in this foundational level. And then we move on to the steps in time series analysis. The first step in time series analysis, you have to do exploratory data analysis. First of all, you have to plot the time series to visualize the pattern, trends, and seasonality in your data. And then you can decompose the series to separate the trend, to seasonality, and residuals. So these are parts that we do in time series analysis. So when you are evaluating the effectiveness of a time series analysis research proposal, you have to look at the steps, starting with the exploratory data analysis. Was there exploratory data analysis that was conducted? And then now testing for the stationarity of the time series. So this is what I was telling you, that we have values that we check. So for example, we can use tests like the augmented decay Fuller, which is the ADF. So we can be able to use it to test, to check for the stationarity. So that's very theoretical, and we can compare it with the theoretical value. And also, if there is a need that the data is violated, the test is violated, and then we have to perform differencing. The way we said that differencing is used to change the non-stationary data to a stationary data. And then we can do model identification. So we have to plot autocorrelation function and then perform partial autocorrelation function to identify the order of AR and MA components. So these things come with order. The AR, the autoregressive, and the moving average come with orders attached to them. So it's good for us to identify the orders, and we use the concepts of ACF and the PACF for us to identify the orders of the components. That's why you'll hear someone asking which order is your time series model. Which order is your time series model? So someone is referring to the autoregressive. Which order is the autoregressive and which order is the MA components of your model? And then the model fitting. So here you choose the fit. You fit the chosen model if it is the ARIMA, and then you evaluate the model using the metrics like the archaic information criterion and also the Bayesian information criterion. These are statistical analysis in time series that you have to go in depth for you to be able to do the modeling, model fitting in time series analysis. So that's the archaic information criterion and the Bayesian information criterion. They're also associated with some specific threshold values. And then now you can do forecasting, which involves the use the fitted model to make future predictions, so that you can now plot the forecast along the historical data for composition. And then from there, after you forecast, you do model evaluation to split the data into training and testing sets, just to check how effective or the performance of your model, whereby you have to look at the mean absolute error and the root mean squared errors. And then you can now be able to also plot the actual and the predicted values to visualize the model accuracy, so that you can rely on your prediction. Yeah, and then some of the tips, practical tips, is just the data pre-processing, which you looked at how to look for the missing values, checking outliers in your data, ensuring that the data is uniform at uniform interval. Then the model validation, you have to conduct model validation, parameter tuning, you have to transform different parameters, and then you have to have some domain knowledge on how to refine and how to refine your model. So some of the useful Python libraries that you can be able to use in order to perform the time series is Pandas, NumPy, Matplotlib, and Seaborn where necessary, and also you can be able to perform stats model and skitlearn when you want to predict the machine learning algorithm, which is skitlearn. And then the statistical modeling and testing, you can use the stats model. And then for visualization and yes, you can use Matplotlib and Seaborn. And for numerical operation, you can use NumPy. And for data manipulation and analysis, you can use Pandas. So I think I have to share with you the data set that you're going to use just to have an overview of time series. And then from there, you can be able to advance more on it based on the knowledge that we already have. We are not going to use majority of this because I just factor them out because they're beyond this foundational level. So we cannot be able to use all this. So I'll just drop them, and then we'll just be able to visualize what we can be able to visualize. So let me stop sharing so that I can share with you the data set via email, so that you can also have the data that I also have on my end. I have not uploaded it on the learning management system. So far, George, how is time series?
I think it's a bit practical. And,
Yes, yes.
I think it's straightforward than I find it straightforward than ANOVA. ANOVA is
Yes,
how a bit you need a bit of statistical analysis. But
yes.
for time series you can relate. I was going through an article on time series, so
Yeah.
I think I found it to be it's friendlier
Yes,
than,
yes.
than what we covered last week.
But the analysis of variance and the analysis of variance is is straightforward as well. So
Not bad.
yes.
But you see, when you have time and series, at least you can relate. I was I
Yeah,
was
yeah, 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 yeah. I get. Yeah.
I was thinking aloud, when you say analysis of variance,
Yes, yes. Thinking
so
loud.
we are doing analysis of differences
Yes, yes. Of variations.
or variations, exactly, or variations.
Yes.
Yeah. So I was just thinking aloud. Those
Oh,
terms.
is as well practical because
Mm.
sometimes you may want to find out uh, the association between some scenarios with themselves, like if there is an association between gender and maybe is it associated to maybe let's say a particular of course it's just in line with the it's just in line with the what we call a chi-square. How did you find a chi-square?
I think it's in the same category with ANOVA.
Yeah, because now for chi-square we look at the categorical variables. So I have shared the email for the data set. So at with the chi-square we look at the categorical both categorical data, while the other one we look at the continuous and categorical. Mhm. So just check the data so that we can be able to just use it to visualize some time series plot. So once you have it, you will let me know. Today we are just sharp onto the point because we're finalizing, and these classes
I think
it's just the introductory part. Did you got?
yes, I've downloaded it.
Okay. So do your thing. So what you'll have to do,
Mm-hmm.
I would like you to share your screen
Mm-hmm.
and to sharing your screen. So we'll be importing let's just import the common libraries that we used in the previous session. We are not going to use a different library, so you'll have to import. Just share your screen. So you'll have to import pandas, import numpy, import. We are not going to use numpy, so import pandas, import matplotlib, and import seaborn.
Okay, it's coming up.
Okay.
Can you see my screen?
Yeah, I can see Yeah, there we go. There we go. There we go. There we go. So we have started by importing it. Maybe you have to run the pandas first and then pd. pd.read csv.
Yeah.
Right. Yeah, so we import Seaborn, we import the numpy, oh, not numpy, the matplotlib dot pyplot, not plotlib dot pyplot as plt
Any other?
dot pyplot dot pyplot, yeah, as plt.
Yeah.
plt. Yeah, so we have imported the data. So maybe you just print some first 5 rows of your data so that we can see how the data looks like. And maybe we check the dimension of your data using info, using shape, so that we can check the dimension of your data. So we have 2 columns and 1105 rows. So maybe drop if we have null values. Drop if we have null values. df.drop na. Drop na, not df. You're using the data, so you don't have to use the df. So it's drop na, not dot. Yeah, like that.
And also,
Yeah.
you need to, I didn't see
Yes.
how to handle outliers. I haven't seen the notes
Yes.
on how to handle outliers. Please share.
There are a lot. Yes. I'll share with you. Okay. So that means we had some missing observations. So out of 1105, we have 1095. Okay. So from there, we have just seen that. So what we do currently, maybe you can just print the info, the df, the data.info, so that we can check data.info, so that we can check if we have null values, the data types. Data.info into quotes, into close the parentheses. Close the parentheses for the info, the parentheses, use the parentheses at the end.
Okay, now?
I can't see your screen changing.
Oh, it's not changing.
Maybe
stop and share.
It's network. Oh yeah, and share again, yeah.
What about now?
Yeah. Okay. So Can you call df? Can you call there df dot
df for data?
df dot df is equal to data. Df is equal to why is screen not changing? But I think I'll just be patient. Let me see. Okay, it's coming. Df dot df is equal to data dot drop na. Let's see.
Drop na.
Then close the parentheses, and then you hit enter. Okay, so maybe look at the info. Yeah, it should be like that. So can you compare the above results and the bottom results?
Are different.
It seems yeah, they are different because temperature seems does not have null values, because the other date that was continuous on the data was for prediction. So the dates that were extending were for prediction. So we are not going to predict, well, just for prediction, like we want to predict. So we add more dates at the end. So that's why we had those extension. But of course, your original data, you have it, you can use it to explore on how you can be able to predict the trend. So up to there, so we have seen, now we have that data. Now we want to let's say we want to, so you see the data type for your date is not
date.
Yes. So you have to convert it to date so that it can be detected during the time series analysis. So I'll just share with you the function. So right now our data we are using is DF. So I'm sharing with you the expression that we are going to talk about. So we are creating a function that we can be able to use to prepare our data to become date data.
I copy this,
yeah.
Okay.
Become date data. So yes, so function to check and convert to date time. Invalid passing will result in not like NAT. So something like that. So what we do is that we define a function, we call it save to date time. You can call it something else. Naming function has no, as long as you follow the rules. But we just name it save to date time. Like we are converting it, and then we are calling the data type date underscore string. So we are calling a parameter, an argument in our function. We are giving it an argument. Our function, we give it an argument. And then we use the full colon to indent our Python code. And then we do the error handling in Python, where we try to return the PD dot. So we will be returning, you see, we are creating a general function that we can now call it on any other data, and we can be able to convert it to a date type. So we are creating a general function. So we are referring to the PD, which is a data frame, which is a data frame or a data manipulation and analysis. So PD dot. So we are calling a method in the pandas known as to date time, and then now we are referring to the argument, our argument, which is date underscore string. You can give it your name, and then comma, and then format. Now we are formatting it. So this format has no problem. So we specify the date, month, and the year. But it can still as well be formatted as the year, month, and date, which is day. So it has no problem with that. And then from there, we proceed to apply the function to convert the date column. So we apply the function to convert the date column. So we call the date column in our data. And then now once we have our function running, so exemption, except will for the value error will return whenever we'll have a value that is error. Instead of returning the error, it will return PD dot nat. So it will be returning nat everywhere whenever we have an error. But it will try to return. In the first case, it will try to convert. If it fails to convert, it will return not NAT. Instead of returning an error, it should return NAT in our data. So it will be filling the data that have not been converted to date to NAT, which is just like none. Invalid, like invalid, yes, invalid results. And then from there now we apply the function to convert the date column. So we call the column from the data that we have. We say it is equal to, of course, and then we call it again. Remember, we are renaming it. We are renaming, we are carrying an operation on it where it is. That's why you see we are calling it the date column at first, and then we say equal to, and then we call it again. Remember, we could have named it something else, but now we want it to be on the same data. So we just call it itself, we assign it another value. So another value that will be assigned is the safe date, safe to date time, the function. So we'll be applying. So we say dot apply the function. We call the function into the quote, into the brackets. And then now we can now print the new data that is in terms of date. That is in terms of date. So when you scroll down, you see your data has been arranged in terms of year, month, and then the date. So it is different from the previous data. It's different from the previous data. So maybe try to do what? Try to check the shape. Try to check the shape before we convert it to an index. So before we do any analysis of our data time series data, convert it to an index. So just call the
shape.
Just the info, the shape. Yeah, the shape. Okay. So right now we see that we still have 2 columns and 1095 rows. So we want to convert it. Still, it is not. Try to check if it is okay. It's dead. So just try to check if it's dead now with the info.
Date time.
So the type has changed. Yes, the type has changed to date time. And now we want to make it an index. We cannot predict using it when we have not converted it to be an index. So we want to set the data to be an index in the same place. So what we do, when I start dictating here, the whole code to take time. So I just share with you so that you can, it's just simple one line where we just call the dot set index column, dot set index from the pandas library in the chat section. But it's just short. Yeah. So you just call the dot set index where you can see how it will change the orientation so that it can be now detected as a time series data. So run it. So maybe you df dot head to see how it has rearranged. Now it has changed our date data to index. You see? So it is an index. When you look at that and look at that, there is a difference. There is a difference. So from there, now we can use that data. While date being referred to as an index, I think you could have used it before we convert it to an index so that you see what will happen. But you can do that later. But you will know, you will see what will happen. But you can do that later. So we want now to use that to plot. We want to plot a time series. We want to plot a time series. Want to plot a time series using the matplotlib and daily temperature. So let me just daily temperature is that. So plot the time series. So that's why we said the first step you do is just to plot the time series to check how your data looks like. So I'm sharing some code in the chat section so that we can see how we can be able to plot the time series. So our data is containing some daily temperatures. Yeah, so just scroll down. Just scroll down. Okay. So plot the time series. So now here we can be able to. This is the procedure of converting your data to a time series data. The procedure we have followed is the procedure of converting your time series data to a time series data. Your data to a time series data. And now we start by calling a function known as the method known as figure from the matplotlib method, and then we give the size. You can change the size the way you want in the fig size to see how the size of the chart will be. And then we call plot also. Plot. Now plot is what now is going to plot our time series data, the DF data, and then we are labeling it. As daily temperature, and then now the legend you see, something like a legend you see there at the top of your chart, a legend, the blue line with an explanation daily temperature. Yeah, and then scroll up so that you can see the there. Yeah, so title, we give the title from the PLT dot title. We give the title, and then scroll up. I cannot be able to see. Then we can be able to give the label on our x-axis, which is date, and then we can be able to check the label on y-axis, which is the temperature, and then welcome Irene. Welcome Irene. So, and then we can check on the of course we add the legend by calling the legend method, and then we plot everything. We show everything on our plot using plt.show as one plot. So that's the time series data that we have. That's how we have plotted it. And maybe we can now just look at what we can uncover. Which insights can we uncover from this time series analysis data here without even going into the in-depths of time series model? So we are looking at the foundational level. So we are just looking at the view. What can we see from our data? Maybe I hear from George. What can you see from the visual? What can you see from that visual? What can you see as a data analyst
from the
that visual?
We can see between this is about the year 2006, September.
Yes, yes.
There was a spike in temperature. We have the highest peaks in temperature. And then January, I think January of 2006 and 2008, we had the lowest temperatures.
Okay. That's nice. So Irene, you have just joined us, but now you will not hesitate inviting you to comment on the time series. Today you're looking at the time series, introduction to time series analysis. We have looked at some key components of a time series data, which we said is, the first one we said is trend. The second one we said is seasonality. The third one we said it is cyclic. The fourth one we said it is a noise. So maybe George.
Yes.
What do you think from the components? Which components can we see in our time series data among the four?
Among the four, that is
the component we had. The first one is trend. Second one
trend.
is seasonality. Third one was cyclic. The fourth one was noise.
Noise. I think we can see some trend.
Yes.
We can see some trend from January all the way up to September.
Yes.
The temperature is rising. Then when we get to July there, then we have a drop. We have a drop in temperatures up to around maybe October there. Then January, then the peak. So you see, we have some trend. Even graphically, you can see like a sinusoidal wave.
Yes.
Yes.
Okay, maybe we hear from Irene as well. So Irene, welcome to today's session. And maybe what can you see from this? Yeah, from this time series. What can you say?
Probably
so this data is about temperature. This data is about temperature from the year 2005 to the year 2008. So yeah.
Probably it's seasonal. I don't know.
Yeah. Seasonal. Yeah. So when we look at okay, nice. That's nice, Irene. Thank you for joining us. And I wish you could have been here since we started, because we started with looking at what trend is, what seasonality is, what cyclic is, and what noise is. And from that, when we start from 2005, which is January, for me, once I talk about time series data, I must first of all check, is the data changing monthly? Is the data changing quarterly? Is the data changing half a year? Is the data changing yearly? Is the data changing beyond 1 year? And stuff like that. First of all, is it changing? Is it like having trend? Is it like having something like we can see and say, no, there's a pattern here? And remember, when we were defining these terms, we said, first of all, you check when there is trend. Yes. Once there is trend, now we come to seasonality. Is there seasonality? Is there variation in less than 1 year? Yes. We can see here we have 2005 January. We had some downward trend to, maybe we can call it, let's call it the first quarter of 2005, and then which is from January to March. And then from March, I don't know if you see that the lowest point is around the end of March. The lowest point on the from 2005-01. Yes, the lowest point is around March, there. So there is where we expected the lowest. We experienced the lowest temperature, and now we started experiencing an upward trend, which is now like the second quarter of 2005. So the second quarter of 2005, from that to June. Yes, there was an upward trend. Yeah, there was an upward trend there. Of course, some days you may experience some spikes, but yeah, a trend, we look at an overall view where we can say up to June you experience an upward trend, and then another quarter which comes in, it started coming down from that June. it started coming down. The peak started coming down to up to September. To up to September again, just down and down and down and down. So you can see some kind of trend in this our time series, in this our time series data. That is less than 1 year. So you can say it's seasonality exists, trend exists, and of course it is now beyond. Of course, the trend here, it's seasonal. We can see. Let's check the year. Let's see the year 2006 January. Is it having the same trend as 2005 January? Let's see. What can we say? Yeah, I think it is kind of having similar experience.
Yeah, it's following the same pattern.
Yeah, the same pattern after a particular year, the same flow. So this kind of data is easier for you to rely on this historical, for you to predict the future, what is likely to happen even in the next 3 years. You can use this data to predict what actually happened in the year 2011. Yeah, so this is how you see. This is the visual part. The value, the theoretical part is where we were looking at some terms that can help us to check if our data is having some trend, some pattern, do some decomposition. So we were looking at some terms in time series, checking out the autocorrelation, if autocorrelation exists. So sometimes it's not just that, it's just we are just having pattern. Maybe there is autocorrelation existing. We looked at those terms and then differencing. Difference is a method of converting your time series, if time is not stationary, to be stationary. So we have things like lower bound, upper bound, that you can be able to compute from your time series data. But of course, you can do in-depth analysis of this. So maybe if George, you can share the code with Irene from the start. Maybe I start with, let me just share the data with Irene so that she can also reach where we've reached, because this is what we are just covering today. It's just a scratch on time series analysis, so that when you do the advanced level of Python, you can be able to relate about what we learned. So you can just share in the chat section. Let me share the data set with Irene. So the dataset is shared. So so Godfrey, what do you suggest? Not Godfrey, George. What do you suggest? Do you stop sharing your screen and then
I think so. I think that's the best. Yeah. Then we walk.
Yeah, stop sharing your screen. Yeah, and then we take Irene through.
Yes.
Step by step. So Irene, check your email. for the data you download.
Okay.
After downloading, then you can open your library. So maybe I should also use that time to download this theoretical side that we looked at with the George, so that I can share with you, so that it can be easier for you as well to to digest. Yeah, so let me pull this. Let me post the theoretical that we with George in the learning management system, so that George also can have the same. And before Irene, you share your screen, ensure you have the material downloaded from the learning management system. So I want to call it time series. Okay. So download the notebook that we have shared on. I've shared in the LMS. So you just check your email. You'll see a notebook that has the theoretical, so that you can also have the theoretical. And maybe download the same and have it at your end. Open it, and then you share your screen. So next class, which is Wednesday, is going to be our final class. We'll be learning on. We'll be doing introduction to machine learning. For machine learning, we will have a practical view of the machine learning. We'll choose between binary logistic regression and the multiple linear regression. Yeah, but majority of the cases that we have in our real world is binary logistic regression, majority of the circumstances. So I think we will just introduce binary logistic regression, and regression analysis for machine learning is just simple once you know the other regression analysis, the theoretical analysis, without building a model, machine learning model that you can be able to use to test the data. So from there, we will be sharing a final project on Wednesday, which we'll work on. We have a data set that you have to explore with the problem statement, so that you can be able to leverage on, use the resources we give you, use extra resources out there. There are a lot for you to be able to solve the problem that we are going to give you to handle about Python data analysis. So it is the best way of learning by doing a project. The project you can now is a public project, public data. So you can, of course, share your achievement on your socials, because it will require you to prepare a presentation, a PowerPoint. So maybe that PowerPoint you can upload it on your LinkedIn, and then you can also actually, of course, you'll be showing the achievement you got, from the analysis you got. Plus, you'll also have your notebook as well. So Irene, if you're ready, you can let me know and you can share your screen. All right. Thank you.
You can see my screen?
Yeah, we can see your screen. So, introduction to time series analysis. So we looked at what time series analysis is. We defined what time series is. So a time series is a sequence of data points collected or recorded at specific time intervals, and often over a consistent period. Yes. So these are the theoretical parts that you can be able to go through later. So you scroll down to, hope you downloaded the data as well.
Yeah.
Okay. So just scroll down. So these are the theoretical parts that you can go through. Even this recording will be available. You can listen to how we talked about these concepts of time series. So we talked about the components. First thing, just go to the components so that I can talk about them. The remaining things you can go through later. So go to the components at the top. So whenever you meet data that you want to consider it for time series analysis, the 4 components, you must check the existence of the 4 components of your time series. So you have to check for the trend, you have to check for seasonality, you have to check for the cyclic patterns, and you have to check for the noise. And then from there, you will meet some key concepts like the autocorrelation, differencing, stationarity, non-stationarity. And then now you will meet some time series models like ARMA, autoregressive moving average, and ARIMA, which is autoregressive integrated moving average. You need to, for you to learn this best, you have to start with looking at what is autoregressive, what is moving average, then what is ARMA, which is the ARMA, then what is integrated now, which is ARMA, ARIMA. Remember, we have ARMA and ARIMA. So ARMA is where we have autoregressive and moving average. And then ARIMA is where we have the integrated part. And then SARMA is where now we have seasonality, the extension of ARIMA. Yes. And then exponential smoothing. So these are terms that you'll meet in the time series data. So for this level, we don't go in depth into the time series analysis, but we give the foundation of the time series analysis that enables you to get started with it. And then from there, we have a lot of steps that must be followed. You start by, which we just did in the previous, where you got us, we did the plot to visualize the patterns and trends and seasonalities. So based on the understanding of the foundational level of time series, that is what we're allowed to facilitate. And then you can proceed with doing the decomposition and doing the stationary testing if your time series data is stationary, by looking at some theoretical tests there, and then also applying differencing when it's necessary, when your time series is not stationary. And then you do the model identification. Identify the model, which order is your time series. course, when you're dealing with ARIMA and AR and MA, you must talk about things with order. Then you do the model fitting. For example, you want to predict based on the data that you have. So you have to do the model fitting, the ARIMA fitting, where you'll be looking at some modeling metrics, such as the archaic information criterion. These are values, and the Bayesian information criterion. These are the values that we use to evaluate the model. And then when you go down, you see forecasting. So you can be able now to forecast. And then from forecasting, you can now be able to do model evaluation. All these steps are usually followed before predicting. So when you see any methodological findings about weather for tomorrow, the condition weather for tomorrow, or on Friday, or on which day, it is actually time series analysis that is usually conducted. And then they look at the accuracy, which we call the model evaluation. Look at the accuracy by looking at the mean absolute error and the root mean squared errors. Error. So we check at this. They help us to know to which extent it's our model accurate. Yeah, and then now from there we use full Python libraries. So pandas, NumPy, matplotlib, and Seaborn for visualization, and then the stats model for performing statistical modeling and testing, and skitlearn for machine learning. That just helps you to do forecasting and model evaluation. Yeah, so we are not going to use a lot of those things there. I just used them in performing another time series analysis, but we are not using them in depth. So you go to your untitled one, your new what? Go to your new notebook and start by loading your data set. So you have to take the path for your data set and then go to your new notebook and then type there. Go to your new notebook, or you can start by going to okay. Yeah, so pandas as pd matplotlib.pyplot. Matplotlib.pyplot as plt. Remove ply, remove l. Yeah, so you can run that, and the next cell, now you can import the data. So you have to copy the path. Yeah, just be patient with it. Yeah, nice. Yeah, nice. Now close your parentheses and change your path. Okay, yeah, that's okay. Yeah, that's okay. That's okay. That's okay. You change that. Okay. Proceed with closing the ending parentheses and run. Hello. I think I'm not seeing if the screen is moving.
I have run my data.
Okay, good. Now let's see the head of your data. It's okay. Let's see the head of your data. What are the first some of the observations? Nice. Then from there now, maybe you see these are some of the things, exploratory data analysis that you have to do by checking how your data looks like. And then now maybe we can see let's check the shape of our data. Let's check the shape of our data to know how many rows and how many columns. So df.shape. Okay.
Yeah.
df.shape. We have that.
2 columns.
Okay. Then once we have seen the shape of our data, we can proceed and check info. We can proceed and check the information about our data. So that is the data.information, data.info as a method. Info as a method. So you have to close the parentheses, open and close the parentheses for the info, and you run. So we can see that we have variation. We have date, which has a number of observation up to 1105, while the temperature has 1095. There's some missing values that we that data was supposed to predict the future dates, but we are not going to do that. So you'll drop the missing dates. So what we will do for us to drop, we need to call a new data df. Then we say is equal to the outcome after dropping the missing values. So it will be df, yeah, dropping missing values, yeah. So dropping missing values. So we use df is equal to, then now we call our data, which is data dot drop na. Drop null values, drop na. Is a method, so we must close with parentheses, open close parentheses, so you run, and maybe you see now the info. Check the shape first, check the shape of the df, because it's the new data we have just named. Check the shape of the data we have just named. Now you see the difference.
Yeah.
We have the missing values. Now we proceed with the new clean data. Now we proceed to checking the info. Again, check the info again, df.info. Nice. So you see there now, date and temperature have the same counts, have the same number of counts, unlike the previous one. Okay. Now, up to where we have reached, now we have to check the data type for date. The data type for date there is known as object. And the data type for temperature is float. So that means we need date to be detected as date, because for time series data to be time series data, it must be date. So how do we make Python to know that this is a date? So go to the session 7, and from session 7, take their code, that code about function to check and convert to date time. So copy that whole cell, copy that the entire cell about function to check and convert to date time. Copy the whole of that, and then you put it in your environment there. So maybe we'll explain what the function is doing. So we define the function using def, and we name our function sef_2_datetime, and we give it an argument, which we sometimes call it a parameter. known as date underscore string, and then we indent for Python to know that it's a function. We indent using full colon, and then now we try and catch, we try and exempt error. We try and exempt error. So this error handling in Python. So we try to return, like now we try to return, we are creating a function, remember? So we are creating a function that we can be able to apply on any data and be able to convert it to date time whenever we are referencing to a column known as date. So we call a method in pandas. While returning, we call a method in pandas known as to date time. And then now we give the argument date underscore str, comma, and then the format for our date. So from there, we accept a value error. Whenever we have a value error, what will we return? We will be filling everything that could have returned a value error with NAT, which is from the PD, from the pandas library. So that's what the function does. Now from there, after creating the function, now we apply it on our column, the df, our data, in our column known as date. So we say is equal to, and then now we call it again. We call that same column in that df. Now we apply the function. We apply the function. We apply the function, which is saved to this time. And then now we check the head of our data. We check the head of our data. So you can just run that cell. If you've understood how the code flows, and you can see how that date is, the data is arranged for date, and how the data was when you tried to visualize the first column, the first cell, the first rows is totally different. So that means that now Python is detecting it as a date data. So you can now proceed and check the info again to compare if it's now detected as date time. So to check for the info, you just do the df.info, because the df has been replaced. The df date has been replaced with the new inputs. So df.info to check if it's being detected as date time. So it is now not an object, but it is a date time. When you check at the data types, above there it was objects. Now it is detected as date time. From there, we proceed, and now for us to plot, let's try to plot this data without converting it to date and time. So go to your session 7. We have just said it's date without converting it to an index. Now copy the plot the series, the cell known as plot the series. Go to the cell known as plot the series. Copy that code for the plot the series. Yeah, plot your series. So you see, George. George?
I'm here.
Yes, this is the step we wanted you to do before we convert it to set it as an index. So you see how it looks like. So you have to convert it to an index first before you can perform time series data. So let's convert our data to an index. So Irene, go to the session 7 and copy the code that is just above the plot. The code that is just above the plot. So
Yes,
we
sir.
want to set a new data column as an index, that one. So we want to copy to format it as an index. So if you do, George, if you do the other way, it will detect it as if you are plotting a scatter plot. It's as if you want to plot a scatter plot. So, and not a time series data. So it will mess everything. So run that, Irene, and then go to the top. Can you just, okay, paste it there. Okay, yeah. Run that. And I want you to check the df.head. See how it will have arranged. None of the date are in the columns. Okay, yeah, I know the reason as to why we experience that. So maybe you'll just have to rerun. You just have to rerun everything. Let's see. Everything. Rerun everything by going to the kernel. Go to your kernel. And restart kernel and clear outputs of all cells. Restart. So you will just reproduce, you will just produce step by step the way we have just done. So just run the top cells, but you will not run the last, the second last. So run from the importing the pandas, and then from there you run the that, run head, run shape, run info. Of course, then you drop missing values. You run your info shape and all that up to the function. Then you stop at the df.info. So check the df.info. Okay, so skip that and run the set the new date data. What's wrong with your What's wrong with your is your date? Just go on top. Just go at the top. Go to the top. Stop there. Stop there. Is your date? Is your date? Can you run session 7? Can you run session 7? Just run session 7. Just run everything session 7. Just run, go to run. Go to run. Run all select run all cells. Run all cells. Still running. The kernel is busy, so just wait for it to see. Still running. Almost. Should be done. No, not yet though. So there's an error at the top there. So just go up. Oh, okay, the data. Okay, just go up. Let's see where the error is. Oh, the directory. Change the directory. Change it to your directory. Just change my directory to your directory. Yeah. At the top, go to the cell. Go to the cell. Not there. Just change the cell there. Yeah, that part. Okay. Just replace it with your code, your location. All right. So if you have replaced, have you replaced the /? Yes. Place the backslash to /. Okay. Now you can run again. If you remove the quote to the beginning, there is a quote, double quote. So yeah, okay. You can run again the way we did. Okay, scroll down. Scroll down. Yeah. So the first output was for the matplotlib and the down one was for the Seaborn. So I think your environment for the your notebook was corrupt, so the date was corrupt. So just go back to your untitled one. Go back to your untitled one. We tried rerunning everything, but it was not rerunning. We tried to. That is okay. Don't run all cells. Don't run all cells unless you delete the other part that we plotted without having defined to set index, and then you run. Down part, the lower part. Especially here, the DF, is it that date? It's saying the date is not. Of course, it's just okay. Just go down. Data in the. So maybe you check the DF. Check the measurement for the DF. Check the info. Check the info. Okay. Yeah. Check the info there. df.info. Just check the new cell. Date.info, so that we see the new cell down, not at the top, just down, because there we see we have date just down there. Yes, df.info. Yeah, you see we don't have the date, that's why it is complaining. So we don't have the date, that's why it is complaining. So data has been detected as a value and been computed. So what we do, scroll up. So what we do, we have to restart the kernel. Let me see, scroll up. At the top we have date, and then after the df, we just have to restart the kernel and see. Restart the kernel and clear all outputs. Yeah.
After
We start-
session 9, the date disappears.
Yeah. Restart that and we see. But yeah, just restart that and then we'll see how we start.
Restart kernel.
Yeah. Restart and clear all outputs. We want to clear all outputs. Okay, so let's go step by step. So run there.
All cells or each?
No, each. Just run each, so that we go step by step. So we drop null values, and then we proceed. We check the shape. We do the info. Yeah. So run that info. Okay. So run that one. Run now the function. Run now that function. Run it. Let's check it is info, and also let's check it is shape. Run it. So let's check its info and then also check the shape.
Okay.
Check its shape. Check its shape. Insert a cell above. There is a way you can insert a cell above. Don't delete that. Insert a cell below. You see those? Yeah, that one. Yeah, df dot shape. So that we just see if it will tell us it has 2 columns.
Yeah, it does.
It has 2 columns. Now call that df thing. Okay, check now. Run the set the new date column. df dot set underscore. Okay, so just run that.
Oh. Repeating the same error.
Yes.
It's repeating the same error.
Why am I not seeing on my end? I don't see the output. I don't see the output on my end. So maybe you try to. Is it typing that? I don't think if it is typing that, that brings the problem. None of the dates are in the columns. And when you check the df now, if you try to check the df, it is now maybe bringing it without the date. Just try to return the df.
When I run the shape, the second time it
The
only
info?
brings 1 column.
Oh, the shape as well.
Yeah, after this error, I've run the
Yeah.
shape.
Okay, so what you'll do, you'll just create a new. You'll do it later. You just create a new notebook, and then you do step by step, and then you'll give me feedback.
Okay.
Yeah, you'll just create a new notebook. Sometimes notebook may